is not is indirect proof. So there's another so indirect reasoning. Let's start there. Have you guys ever done a Sudoku puzzle?
Yes.
Yeah, but
The rules are in each row or column you have to have numbers 1 through 9. You can only use them once in each row, in each column.
And in the 9.
Oh, yes, thank you. And in each box or square, there's the numbers 1 through 9. All right, so basically, in these, most of the time what you do is a form of indirect reasoning. Like, you eliminate choices that would not work. For example, let's see if I can find one. Here. So if I look at this box right here, there's 9 has been used in this column, and 9 has been used in this column, and 9 has been used in this row. And so my only options for 9 in this box are there and there. That's the choices. So what I've done is I've indirectly been able to figure out that, okay, 9 must go there or there. Kind of work backwards, essentially, to figure that out. I haven't done a Sudoku puzzle in years, so you guys might be...
These are fun.
Yeah, they're pretty fun. The point of this is it's kind of indirectly getting to what you want. So there's a form of proof that's called indirect proof. And what that is you kind of work backwards to get to what you actually want. Yeah.
Wait, so since tomorrow's Friday, we should just do those during class instead of learning.
Oh my gosh,
Should.
please.
Good
It's
idea.
Friday.
Oh,
So
wow.
we just indirect reasoning.
Cool.
great
Yeah,
idea.
what a great idea. But no. So at the top, indirect reasoning is a form of reasoning. Okay, all possibilities are considered. You prove them false except one, so the remaining possibility must be true. This is also known as proof by contradiction. Do you know that word contradiction, like two things that don't work, they add up or work, and they contradict each other? Like people often say things and they contradict themselves because they're like, oh, I said I wasn't going to be at this party, and then you go to the party and it's like, wait, you're going against what you said. Okay, so here's how it works. You temporarily assume the opposite of what you want to prove. This is like the main thing here. You assume the opposite of what you want to prove. You then show that this leads to a contradiction. Basically, this leads to something that's contradiction is something that goes against what you originally said. So it makes something that's false. You then conclude that your original assumption, the opposite of what you wanted to prove, was false. Therefore, the opposite of what you wanted to prove, which is the original thing you wanted to prove, is true. So we'll try to. You'll see it as we go along. These are written as paragraphs. You just write them out in words. There's not a good 2-column form of this and flow chart. No, not as well. You still need to give the reasons as you go along. It's a paragraph proof. So before we try to, I was going to say here. So here's what we'd say. Like for example, let's just look at this one. If you're trying to prove an angle P is a right angle, here's how you start your proof. Suppose angle P is not a right angle. This is not on your page, by the way. Right is not the opposite of it is a right angle. You just basically do the opposite. It's not a right angle. You suppose that's true. And then you work from there and you'll find out that leads to something that's false. So let's try one out. Any thoughts before we try two? So let's do example 2. It's easier to see these in action. All right, so example 2. Given L is not parallel to M. All right, it's very different from normal. Normally we say they are parallel. Prove angle 1 is not congruent to angle 3. So here's how we start these. You temporarily assume the opposite of what you want to prove. You're going to find out that's false. It leads to something false. Therefore, this actual statement is true. So here's how we start. You can say assume, or I like to say suppose, opposite of this. The opposite of angle 1 is not congruent to angle 3. Is that angle 1 is congruent to angle 3. Actually not going to need angle 2, that's just in there. Hey guys, back from unit 2, if angle 1 is congruent to angle 3, what do you know about these? They're parallel, yes, very good. So then I just say, all right, well then, L is parallel to M. And here's what you do to state the reason still. Evelyn said it very nicely. Because of converse of corresponding angles. This one was postulate. So here's this is a very short one. We already have this is our contradiction. L is parallel to M, but then here then we have L is not parallel. That's a contradiction. That can't happen. They're both parallel, not parallel. It wouldn't work. Okay, so then you write the word contradiction. Here. I'm sorry. Before you say that, I should say, but it is given. So you say it is given that L is not parallel to M. You can just use that symbol, parallel but crossed out. And that's where you say now you have two things that go against each other. So then you just write the word contradiction, and you finish it up by just saying that what we wanted to prove was actually true. So we assumed the exact opposite of this, and it led to something that didn't work. Therefore, this one actually does work. All right, so I finish up, but it is given L is not parallel, so there's a contradiction. And so I'm going to finish up by saying, therefore, exactly what we want to prove. Angle 1 is not congruent to angle 3. You can again use that symbol if you want, the congruent but crossed out. I'm going to finish up with example 3, but so quick review. Suppose the opposite of what you want to prove. Angle 1 is actually congruent to 3. Well, that means the lines are parallel. But it was given that they weren't parallel. And so that doesn't work. That's a contradiction. Anything I can answer in that one? Here's the last one I want to do today. And then we'll just work on a few problems. By the way, on these, a quiz or test, or I would tell you, hey, use indirect proof. I would tell you to use this specifically if I wanted you to do it. All right, so in this problem, we're given A and B are not complementary. Prove angle C is not a right angle. So what we're going to start with is the opposite of this. Opposite of what you want to prove. So I'm going to say, suppose angle C is a right angle. Oh. And what's going to happen is it's going to lead us to a contradiction here. All right, so here's what we're starting with. Angle C is a right angle. So it measures 90, right? I'm going to put, so measure of angle C equals 90. By definition of right angle. On this one, you got to think, well, I'm trying to say A and B. I'm trying to get the opposite of this. I want A and B to be complementary. Well, C is 90. The whole triangle is 180, right? So I can say the sum of the angles. Let's see if I should put. Yeah, I should. Let's write it as an equation actually. I'll put so measure of angle A plus measure of angle B plus C equals 180 by the angle something. So we have measure of angle C equals 90, because there's a right angle. And then we have A plus B plus C altogether equal 180 by the angle sum theorem. Well, can't I just do a normal, what we do with this? I can plug in 90 for A. And then I'm going to subtract it from both sides. So I'm going to do, two steps in one here. I'm going to say, well then, measure of B plus measure of angle C will equal 90. I was going to say by substitution and subtraction. If you want me to do, I can do one step at a time if you want.
No, C is the right angle.
C's the right angle.
My bad. I see what you're saying. So I should leave. There we go. Thank you. So measure of angle A plus B. So you could just plug in 90 as substitution and then subtract it, or you can on these types of proofs. I'm just combining two steps in one. I'm going to say, well, A plus B equals 90. I substituted and then subtracted 90. So by substitution and subtraction. And subtraction property. Okay, well, just plugged it in, subtracted 90. Doesn't this mean that A and B are complementary? If A plus B equals 90. So then I'm just going to stay. Sorry, I should have left more room on this one instead of example 2. But so I say angle A and B are complementary. By definition of complementary. Complementary angles. Let's see, so A plus B equals 90. We knew that. Well, that means A and B are complementary. That's just what it means if they sum to 90. But the problem is up here, you say, well, we were given, though, that A and B are not complementary. And that's the contradiction. Okay, so I'm going to finish up by saying, I'll say, you can say a word like, but angle A and B are not complementary. Really, I think I should have said it's given that they're not. So I'll just say, but angle A and B are not complementary in the given. So basically I have this. They are not complementary, but then up here they are complementary. And now I can write the word contradiction. Alright, once you write the word contradiction, you said, alright, you found two things that didn't work. Two things that were essentially opposites. And so then you say, therefore, what you actually wanted to prove is true. So I'm just going to say, therefore, my original opposite assumption was false. I'm not writing this, but this, what we want to prove is actually true. So therefore, angle C is not a right angle. Okay. So again on these, assume the opposite. So suppose the opposite of what you want to prove, not what is given. That's the biggest mistake I remember seeing in these. Assume the opposite of what you want to prove. You'll work it out just naturally as a proof, and you'll get something that doesn't work. It should be the opposite of this. You write contradiction, therefore what you want to prove is actually true. Okay, anything I can answer on proof by contradiction? Okay.